Hey, Amir.
Hey, Jim.
How are you?
I'm fine. We are both early to the event.
Yeah, I got in early. Matt's supposed to be here in the next 5 minutes or so, just to do a system check.
Yeah. So I'm here and I'm getting back to the background, and I will be here as a viewer.
Awesome. Well, yeah, feel free to jump in and ask questions and comments and all that stuff too. And yeah, by the way, yeah, you asked a few questions on yesterday's webinar.
It was a nice event, and I must say that without you, it would be, it's important that you push the discussion, manage it, maneuver things. It's such an important role to be the moderator.
Oh, yeah, thanks. I've had a lot of practice doing these with the NADOG. My own community, we did 52 web events last year, just one every week. So, wow. And then the year before that, we did over 100.
Wow. But I guess it's a bit different.
Yeah, a little bit.
Manage 10 minutes per person and sees that the slides doesn't move. And usually, I guess in NDOG, it's not your things to watch over.
Yeah, the NADOG events are more like this, where we've got one speaker on, everybody comes on, they talk for 30 minutes, and then we ask questions and stuff, and then we wrap it up.
I'm arranging meetups, so I know that when you arrange a meetup, the person just comes, and if he's good, and if he's not, then it's fine. It is still nice, and you do not have to in a way to manage him, to manage the speaker. So it's a different experience.
Yeah, the physical meetups I find it's a lot less important, the content. You want it to be a good talk or
I mean even online. We have today many online meetups which are like what we would have today. A speaker speaking about something, questions from the crowd. So it's different than a few speakers or like a webinar, people talking with each other, and at the end, interviewer, you are the interviewer. So it's a job. It's tough. And yesterday, it was yesterday, right?
Yeah, it was yesterday. Yeah.
Yesterday was tough. And you managed it very good. I enjoyed it.
Thank you. Thank you very much. Yeah, it was fun. I'd love to do that same event again, just get a different cast in, different stories, and I think it'll be fun.
Great. So I'm at the background.
No problem. Hello there, Neo.
How's it going?
Good. How are you doing?
Oh, not bad. I just saw your email come through.
Oh, cool. Yeah, thanks for jumping on. It doesn't start for 20 minutes, but I got on early. Our speaker is going to come on in just a second. Just wanted to make sure his mic is working and all that stuff before we get started. But yeah, you're welcome to stay on. Where are you located?
Irvine.
Okay, you're close. I'm just up in Glendora.
Then wasn't NADOG started in Irvine, you said?
Yeah, the first event we did was in Irvine 7 years ago in April.
Wow.
And yeah, we're going to have our first in-person event in 2 years next week, actually, in Irvine. So we're kicking it off again in Irvine. Well, I think it'll technically be Tustin, Irvine.
Oh yeah.
In that area.
Yeah. I was thinking about moving to Tustin just because it's getting, I don't know, they jacked up our prices here like 25% or something like that, but they're building a lot of new housing in Tustin. So, and it's not even that far. I could walk to Tustin.
Oh yeah. It's pretty much the same city. Yeah, we actually might have to move the venue. I got a call last night from, we're supposed to hold it at Taps Brewery. And so we had it all arranged, deposit made and all that stuff. Then they contacted me last night and said, hey, our room's no longer available. So do you want to reschedule the event? What do you want to do? What are you talking about? It's no longer available.
Yeah. What the
They wouldn't
hell?
tell me what the situation was. They said just that the room isn't suitable right now. I don't know what happened, if there was a flood or they found a rat or what. But so now I think I found a new place already, but I'm just waiting to get all that confirmed before I make the switch because I don't want to reschedule the day.
Yeah, that's really weird.
Yeah, they've been really weird to deal with. So I don't think I'm going to go back there.
Yeah, it just seems odd that they wouldn't even explain what happened.
Yeah, she
that-
said due to unforeseen circumstances, and I was like, okay, well, is the city saying you can't do indoor dining or something, or what's the deal? No, it's not the city, it's us, and the room's no longer suitable. So
sounds like someone fucked up.
I sort of think they double booked it or something. Who knows?
Yeah.
So we got the shaft. She goes, well, you can do it in our main room, but we're doing trivia night that night, so I don't know if that would interfere with what you're doing. I was like, are you joking?
Yeah.
Like we're gonna
That's
be talking and you guys are gonna be shouting out trivia questions?
Yeah.
Yeah, let's do that. Sounds perfect. But I'm excited for that talk too. Are you planning on going to that event?
Which one? Trivia night?
No, the Nate Dogg event in Tustin or Irvine next week.
Let me see.
It's Wednesday at 6 p.m.
I wonder why I didn't get a. Let's check this out. Now I want calendar. Okay.
You can go to nadog.com/events too, and that has like all of our stuff listed there.
Oh, looks not even. Oh yeah, but it says it's 5 days for some reason on the invite.
Oh, yeah, somebody cut that. It was like from Wednesday to Sunday, something like that.
Yeah, I couldn't figure out how to edit. Yeah, it didn't let me edit it either. It's like it's auto-populating or something.
Oh, jeez.
Yeah, I've got it on my schedule.
I think I since fixed that. Yeah, it's only 2 hours. Don't come with a suitcase.
Yeah, I got that on my calendar. Let me put this on here so I remember that I can hear it. Let's see. Okay, there's the DevOps and tab. No. January 11th. Okay, this is it.
It's weird right now. I wouldn't be surprised if like next week they decide to close everything down again, but so far so good.
Interesting. Yeah, this one wasn't even on. I thought this meetup was next week's meetup actually.
Oh, you thought this one was?
Yeah, that's why I was. I was thinking, how did I got my dates mixed up or something.
Yeah, next week we have Brian Keith. Actually, Brian Keith 7 years ago was at the very first NADOG event, and this will be his first time speaking at one. And he's going to talk about measuring developer productivity, and he's going to be referencing Accelerate. I don't know if you've read that book, but we've got some copies of that book to give out too.
Oh, you know what? My boss was talking about that book. That's funny that you mentioned that.
Yeah, it's an interesting book for sure. If you're looking at ways to measure not just developers, but then your overall processes, and they go into the whole first half of the book goes to explaining how they did all the research and which is interesting if you're, if you're interested in how, statistics work and the kinds of things you have to consider. I didn't know a lot of that, so I thought it was pretty cool.
We're lucky if we can keep our developers for any for a longer period of time. I don't know. I guess in India they get offers and then they just jump ship pretty quick.
Oh, really?
Yeah. Our QA people too. I mean, I wish I think we had a vendor come in and talk about getting those kinds of statistics once, but we didn't have any. And actually, do you know Mark Priolo, or I don't know how to pronounce it.
Yeah, I do actually pretty well. Yeah. Yeah, he used to run the continuous delivery meetup group, right?
Yeah, he did. We actually worked together. He's on a like my equivalent team on our parent company side. So I work with his guys all the time.
Gotcha.
But yeah, he I think he got that meeting together, but the vendor didn't. I guess we didn't. I guess we just didn't have any feedback or whatever. I guess because the developers don't want people to know they're not doing anything.
Right. We got our speaker here. Hello, Matt.
Hey, how's it going?
Great. How are you?
I am perfectly acceptable. Just trying to even out my
Breathing.
lighting here a little bit. Is the audio okay?
Yeah, you sound great. Yeah, when you have when you get settled there, make sure you can share the screen.
Of course.
My options over here don't look like they normally do, so maybe you're already able to share.
Okay, let me
If worst case, I might have to make you the host of the event. You'll have all the control, but oh no, it says everybody can share, so we should be good.
oh, then we just have to worry about attendees sharing, that's all.
Yeah.
Let's see.
Yes, well, it says who can start sharing when someone else is sharing, only host. So as long as you're sharing, no one else will be able to take your screen. Okay, cool.
Can you see that?
Yep, we got it.
Fantastic. And I will.
Are you going to go into presentation mode when you?
Yeah, I'll give that a shot in 1 second. Let me just
Okay.
get my speaker notes up on my other monitor.
Okay, that yesterday we did another webinar with Incredibuild and we tested like this and then it looked great. But then when the meeting started, he did this, but then he went to presentation mode and the presentation went onto some other screen.
Yeah, I've had that challenge before, even at conferences, where it's like I had to give the whole deck and not in full screen mode because the projector didn't like something or another. It's always something.
Yeah.
Okay, so that's full screen. What does that look like to you?
Nothing. We're not sharing anything now.
Okay. So that's all right. Let me try a different approach. Let me try sharing my whole desktop down here and try that. How's that?
Now it's perfect.
Okay. Yeah, so I tried sharing just the Firefox browser first. And I guess when it goes into full screen, it's a different ball game. So when I share the whole, just so you can tell future people. So if you share the whole desktop, then full screen seems to work, at least on Mac.
Okay.
So.
Cool.
Alrighty. I guess the lighting looks okay. I'll scoot this back a little bit. So,
Remind me, Matt, where are you located?
I'm in San Francisco.
Oh, okay. Cool. I'm going to be doing an in-person event in San Jose in 2 weeks.
I remember you mentioned that.
Yeah, assuming stuff is still open and all that stuff. Yeah, I'd love for you to come down if that's not too long of a trek for you.
I remember you said it was a DevOps thing, if I recall correctly, right?
Correct. Yeah. That's the North American DevOps Group.
Yeah,
community that I run.
That's outside my wheelhouse.
Oh, gotcha.
let's see. So that looks good. Lighting is reasonable.
If you just want some free beer, then feel free to come on down.
Sadly, I don't drink anymore, but I appreciate it. If you have a tweet, I can retweet something for you to help get your attendance up.
Oh yeah, sure.
But so I can help in that way.
What about coffee?
Yeah, coffee, soft drinks, food.
I appreciate all of that. But yeah, with Omicron, I'm not going to be, and the breakthrough rate in particular, where people are vaccinated and they still get sick, less sick, but they still get sick.
Yeah, I know. I wouldn't be surprised if I was just telling Neil before you came on if these live events have to push because people are getting a bit more worried about Omicron.
Yeah. So my daughter's school does pooled spit testing. So every Monday she brings home a little kit just to spit in a tube, and then they test it. They bring it back on Tuesday. We usually get the results on Thursday.
Oh,
and
really?
her test, and they've been doing this for 2 years now. So she went back to school in person in September 2020, I want to say. And so one of the ways that they did that is that they had this pooled spit testing, and it's been awesome. And so there hasn't been any outbreaks at her school among staff or kids. But this Sunday, they called us and said that her sample came back positive. So we had to keep her home on Monday. And we had to retest twice with a antigen test, and the test came back negative both times. So if it wasn't a false positive on the spit testing side, then she had it and it was gone, and she got vaccinated. And thankfully, she's old enough to have gotten vaccinated already. So there was no indication she was sick or had a problem at all. But it's a huge pain in the ass when your kid has to stay home, and then you have to rearrange your schedule and all that stuff. So it's not worth me going to San Jose. That's the only way to say thank you, but no thank you. I'm sure it'll be a wonderful event and it'll be awesome. It doesn't need me there, and I'm not going to come.
Yeah, no. I totally understand. I actually have my 17-year-old is home right now because the school said that there was somebody in one of his classes that tested positive and is at home now. So we have him here, and I was trying to find a place just to go get him tested real quick, just to make sure. He's actually triple dosed now. He just got his booster a week or two ago.
Okay.
So
wow. A teenager, I guess then.
Yeah, 17. So I'm not really worried that, even if he has it, he's young and he's had 3 shots, he's okay, but I don't want him spreading it around other people.
Of course.
So we got to get him a test to make sure, because then if he's positive, then I've got to get tested. Then that throws a whole wrench into all my plans too.
Yeah. It was real fun to do the research on this, because I haven't done C++ stuff in a little while, and so I ended up researching and coming up with a bunch of content and things to talk about. There's been a lot of amazing leaps forward. I knew about some of the hardware stuff I'm going to talk about, but the linker stuff, there's gold was replaced by LLD, and that was replaced by mold last month. Not replaced, but superseded in terms of performance dramatically. So this has been a great opportunity for me to refamiliarize myself in a focused way with kind of what the state of the art on the tool chain side is. So thanks again for this opportunity.
Of course, no, we really appreciate you coming to share with this group. But we've had some great speakers so far. We've got you. We had a senior lecturer from MIT last month. We've got the ex-chief software officer from the Department of Defense talking next month.
Oh, fun.
So really a nice all-star cast here. So we really appreciate you sharing and taking the time.
Yeah, it's good. I've been in Lua the last 2 years here at Roblox and some Rust. So it was, and I haven't been. I watch like CPPCon and going native in these things. I'll watch the YouTube videos just to like be loosely familiar with everything that's going on. And I do the same thing for JavaScript conferences, just as a principle. I kind of like do that just to stay reasonably abreast of stuff that's going on. But these advances were a thing that I had missed even in my kind of typical passive absorption of these things. So it's pretty great.
Cool. If you don't mind, Matt, to stop sharing, just because I love for people to see my face when they come on.
Sure.
No, but I'll do, so basically I'll just do in about 4 or 5 minutes, just do a quick intro, tell everybody what the group is about, then introduce you, and then hand it over to you. Have you timed this talk? Do you have an idea about how long it is?
Yeah, I think it's about 40 minutes.
Okay, perfect. Perfect. So my intro will be quick. It'll be just a couple of minutes, and then we'll let you jump into it. If you don't mind to maybe just pause a couple of times to see if people have questions. If they're asking questions in the chat and it's in line with what you're talking about, I might stop and say, hey, there's a quick question on this slide.
Okay.
And then we'll leave time at whatever time is at the end for additional Q&A and open discussion. But I'll try to end it promptly at 11 o'clock Pacific time. Hey, everybody, thanks for joining. We'll get started here in just a few minutes. We're still about 2 minutes early, but I'll give everyone else a minute or two after the hour to get logged in as well. Usually I have trivia planned for these things. I didn't plan any trivia questions. No.
You can ask about your background.
Ask about my background?
Yeah, your background window, what movie it is.
That's not any movie. That's a fake Matrix thing, I think.
That's not real code.
It's ones and zeros. Well, it's not the Matrix code anyway.
Yeah. I'm sure they have a name for whatever that code is. Yeah, we actually one of the webinars we did it was, I guess, the week that the new movie came out, we did some Matrix trivia.
How many people are we expecting?
There'll probably be about 30 or so people that are logged in. We had about 65, I think, that signed up. Usually it's about a 50%, 40 to 50% that actually come.
Thank you.
Mm-hmm. But we're recording this as well, and then we'll just do a quick edit where we just trim the ends off and put a nice little bumper on there, and then we'll get that up for anybody who missed as well. Usually these things, we get a lot more eyeballs on them afterwards than are here live. But we do appreciate everyone who's here live because it makes it more interactive. And I just like the feel of a live event better than doing a record. It seems like anytime I record an event, we always mess up and have to restart certain places. But when we do it live, it's like you just you don't have a choice. You have to keep going through it.
Yep.
And I like it. It just makes it feel more real, I guess. Hey, more people coming on. Thanks for joining, everyone. We're going to give just about a minute and a half, 90 more seconds here, and we'll get started. So if you want to grab a drink or something like that, you still have a few minutes. And then I'm going to talk for the first 2 minutes too. So if you're going to miss any part of it, that'll be the part to miss. Nice group here. Let's give about 1 more minute, everyone, and then we're going to we'll get started. This is the MLOC Group webinar, by the way. Matt was sharing the title screen, but I asked him to take it down so you can see my pretty face as we start this. All right, just about 30 seconds, everyone, and then we'll get it kicked off for you. Thanks for joining. Really, this is a great group. By the way, if anyone here is going to be at GDC, the Gaming Development Conference in March, assuming that happens, we're going to plan some sort of MLOC Group event there as well. I'll be out there with Incredible, and we'll do something for this group too. So we will be able to buy you some drinks at that event. All right, we are at 2 minutes after. We're going to go ahead and get things kicked off now. Welcome everyone to this MLOC Group webinar. If you don't know, MLOC stands for Million Lines of Code, and we are an open and agnostic community that focuses on the challenges that come along with things like developing, deploying, managing, testing, anything around some of the biggest applications in the world, where we got the Million Lines of Code acronym from. You can find us at mlocgroup.com. So it's mlocgroup.com. And we'll have some additional events planned throughout the year. Like I said, we're going to be in person at GDC. We've got another event next month. I'll post that link for everybody in the chat in just a minute. But let's get things kicked off here. So today is the 12th of January, 2022. We are live here with the first MLOC Group gathering of the year. I am Jim Schultz. I'm the head of community at MLOC Group. Today's talk is going to be led by Matt Hargett at Roblox. He's a principal software engineer at Roblox, and his topic today is common sense acceleration of your MLOC build. And before we get started, I just want to acknowledge and thank our corporate sponsor, which is Incredibuild. Incredibuild works with many MLOC Group member companies, helping to greatly reduce their build and test times. Most importantly, Incredibuild is a huge supporter of the MLOC Group community by paying for the food and drinks when we do gather in person. So thank you, Incredibuild, for sponsoring this community. As soon as I'm done talking, I am going to post a couple of links in the chat. One is to Incredibuild if you want to check out what they do. And the other one is to our next MLOC Group event, which is on February 10th. That's going to be led by the ex-chief software officer from the Department of Defense. So it should be pretty interesting. So now I'd like to introduce Matt. Matt, I actually came across that video that you did. I think it was the same talk, an older version of this talk. I think it was at CPPCon that you delivered the talk. You can correct me if I'm wrong, but so very excited to see the updated version of this today. And if anyone here has questions during the talk, feel free, drop them in the chat. Matt's going to pause a few times during the talk too, so that if you want to come off of mute, you can do that, but then we'll have another 15 minutes or so at the end of the talk for more Q&A and group discussion. So with all of that, Matt, I know I said I would be 2 minutes and I was 2.5 minutes. Sorry about that. But it's now time for you to talk, and I'll pass the mic over to you to start your talk.
All right. I just
let's see how smooth and slick we are with getting the sharing up. We practice
exactly. Let's go here. I'm going to go here, and then I'm going to go here. Look good?
It looks like we're full screen. Yep.
All right, great. Cool. Hi, my name is Matt Hargett, and I'm going to be talking to you about common sense acceleration of your million line of code build. Thanks to Jim for inviting me for this speaking opportunity. About 10 years ago, I was doing a lot of C++ stuff, and my typical pattern is I'm in an area of technology, I kind of learn a lot, and then I do a bunch of conference talks to kind of commoditize my knowledge before I move on to some other new area of technology. I did that for .NET. I did it for C++ when I spoke at CPPCon and a few other conferences. And it was a lot of fun to kind of refresh this talk for all the new information. So thanks again to Jim and the MLOC Group for the invitation. My name is Matt Hargett. I've been programming since around 1985. I first started programming on an 8-bit computer called the TI-99-4A. I've been an open source contributor since around 1994 when I worked on Linux at a internet provider that I was working at in my hometown of Springfield, Illinois. I'm an author. I co-authored Pragmatic Unit Testing in C# 2nd edition, in addition to numerous other kind of articles in print magazines. I've been an international speaker at technology conferences for over 20 years. maybe almost 25. So most recently at CPPCon, at Black Cat, at React Native EU, Chain React, and JavaScript conferences and things. My Twitter handle is SYKE, and my LinkedIn is just my name, Matt Hargett. It should be easy for people to find. I'm not seeking work right now. Please do not contact me offering me jobs at this point in time, but happy to chat about just about anything else. And I currently live in San Francisco with my husband of over 20 years and our 6-year-old daughter. So here's the kind of lay of the land for this talk. So we'll talk about why revise this talk. The original talk is up on YouTube. I get lots of great feedback about it from people who send me LinkedIn or Twitter direct messages saying like, hey, this thing really helped me. So why revise this talk if it's already been captured in video? We'll talk about that. Why demand fast builds? Going to really explicitly touch on the legacy code quandary, which was a piece of feedback that I got from the original video where the kind of legacy code situation wasn't made really explicit. And talk about, if only it were simple, what are the simple ways that we could try to accelerate our build that typically don't work out immediately. And then accelerating what gets built, reducing what gets built, and then the culture shifts that can result once you actually have a fast build. There's some kind of socio-political ramifications and ripple effects that people should think about upfront as or in parallel with these kind of tactical things. So why are we revising this talk? So in the original talk, I said that running a million line of code C++ build on a laptop in 2014 was not really a practical thing to do in terms of the amount of RAM that was available, in terms of core saturation, in terms of the thermal throttling that happened, and that the portable hardware world has changed since 2013 when I gave that talk. So there's a couple of things. One is that virtualization is mature and fast. Every laptop has hardware virtualization in it that you've bought in the last 5 or 10 years. So now instead of it's like, well, C++ links alone, large C++ links alone being too IOP heavy for virtualized environment isn't really true anymore. You can have a poorly configured virtualized environment where that's true, but there's no technical barrier there at this point. Solid state storage drives are now direct PCI Express, and the amount of money you spend per terabyte per gigabyte per second is relatively cheap for the gains that you get. When I gave the original talk, you need to get enterprise flash drives, EFDs, that had enough durability and enough throughput, and that was just not a kind of a viable thing. And they weren't available on laptops. That's upside down now in a good way. So that's something that's also changed. So now you can get a 1 terabyte drive that has a sustained 4 gigabytes, not gigabits, gigabytes per second. And the amount of money that you save by having a fleet of 5,000 laptops across your developers with the capability pays for itself in terms of productivity gain. Simultaneous multi-threaded virtual cores, or hyper-threading is Intel's marketing name for it, are really now truly wide. So it used to be that when SMT first started, you'd have 4 physical cores, but they'd be kind of shown as 8 kind of virtual cores or 8 cores in your operating system, but they weren't 8 really independent cores. It wasn't 2x the cores really. And between Apple's M1 silicon and AMD's really amazing Zen architecture, specifically starting with Zen Plus and Zen 2 and onward, the kind of instruction per clock gains each hardware iteration that they've had, even between the M1 and now the M1 Pro or the M1 Max, and between Zen and Zen 2, or never mind Bulldozer or Jaguar or AMD's more challenged architectures of the past. Now these SMT cores are effectively double the cores of like the kind of similar, say, AMD or Intel part from 10 years ago. So now when we have these 4-core laptops, but there are 8 cores, but it's a Zen 2 laptop or it's an M1 laptop, that's basically as good as having, not as good as, it's as good as having those same discrete physical cores from an architecture from 10 years ago. They're that wide. memory bandwidth would be the next thing, which is the next item on the list here. So now you have 3D stacked memory that's completely integrated onto the die in the case of M1. That's maybe slightly overstatement, but it's more deeply integrated. It's not a separate memory controller that goes across a bus and has a lot of latency. And now we have huge caches, L3 caches kind of in particular. And in some of these architectures and APUs, you have the shared L3 cache between the GPU cores and the CPU cores. So if you have a kind of a mixed workload there, you're not wasting hundreds of millions of kind of silicon gates on duplicated cache and duplicating L3 data across those L3 caches. So things have completely changed on the kind of portable hardware side. And that changes the original talk. And it's kind of the piece of advice there completely. The infrastructure role has changed. So originally, when we talked about off-premises cloud builds using, I'm not calling anybody out necessarily, but Circle CI or Travis or AWS or whatever, when we gave the talk in 2013, basically those virtualized off-premises cloud builds, the hardware was oversubscribed. You were getting like a fraction of a core. The RAM was slow. The disk was not fast enough and stuff like that. But now off-premises cloud builds are fast and competitive. They're not just one vendor that can give you 32 Zen 2 cores that are all yours and you're not sharing them with anybody. There are multiple cloud vendors that can do that for you. And so now, do you need to have that big iron laptop or that big iron thing to each engineer? Can you do build as a service that's off-prem? On premises is, of course, you could always do, but that's a higher capital expenditure cost. And then the kind of DevOps, particularly on the kind of build side, is no longer seen as a pure cost center. I think that there's been enough kind of incidents that have been like in the public eye where there was not business continuity for a particular for like a build engineer, something like that, and then over the course of a week, 1,000, 5,000, however many engineers all of a sudden could no longer check out, could no longer build. And that can throw off a quarter in terms of what you're planning to deliver. So I think that the attitudes broadly have shifted here, where it's not like, oh, well, there's a person that's passionate about the build, and so we'll kind of humor them or whatever. I think most businesses now see this kind of application DevOps or build DevOps kind of role or team as more of a necessity beyond a certain scale of engineering organization. And then last, the software world has changed. And that's a silly thing now that I see it, now that I kind of say it, but in particular, we have new linkers. When I gave the talk originally, Gold was just becoming mature enough to really be used at scale, even on legacy code, and you didn't have to know a lot of voodoo words or anything like that to get it to work. It was kind of a drop-in replacement, more or less. Now we have even newer linkers that are even more amazing than Gold was compared to BFD or to the Visual C++ linker before. And then we have new compiler developments that we're going to talk about. Facebook came out with Bolt. LTO is extremely mature. Feedback-driven or profile-guided optimizations are, even better than they were before. And so that's something we're going to talk about. And then on top of that, before we talked about disk-CC and Ccache, but at that time, they were effectively not maintained. They did not have a regular release cadence. It was not really a vibrant ecosystem around them. And that is completely different now. Disk-CC and Ccache both have active maintainership and have releases at kind of a regular cadence. Whoops. Oops. There we go. Sorry. There we go. I'll pause after this intro section here for questions. So why demand fast builds? For me personally, it's really all about minimizing waste in terms of a lean software development, or lean manufacturing, and kind of vocabulary. And specifically, the wastes that I really think about with this is waiting, underutilized talent, and context switching. And just to comment briefly on context switching, if you have a 3-hour build and the engineer then switches to a different branch and goes to work on something else, the build fails, they have to switch back and forth between that. Many studies have shown that that kind of multitasking and context switching is not particularly optimal across not just software engineering, but across many different kind of disciplines and things like that. And I think that's the kind of big one for me personally when I'm in kind of individual contributor mode, is if I can actually stay in the problem and stay focused, I will close it out and get a lot more velocity on my thinking and understanding versus when I have to context switch. And then maximizing kind of return on investment. So here's just a couple of quick calculations to give you like an idea of the kind of the time that you can lose or gain. So if your builds take 10 minutes per week and you have 10 engineers and it takes 10 minutes per week for 40 weeks times 10 engineers, that's 3 weeks of engineering time of people waiting or context switching or what have you. If your build, it takes an hour a week. So not that your build takes an hour, but the total amount of time people spend waiting per week is 1 hour times 10 engineers times 40 weeks. That's a quarter of underutilized talent at that point. And then at a more slightly larger scale, kind of beyond early stage startup, 2 hours per week of waiting for the build times 20 engineers times 40 weeks is 1 year. So even at a mid scale, and everybody has a different idea of scale, but to me, 20 engineers, 20 dedicated C++ engineers is mid scale for me. Even at mid scale, dedicated headcount for build operations pays for itself. In terms of if you can take that 2 hours per week and make it 1 hour per week, you just got back a lot of time that you can then turn into business advantage or product advantage or feature advantage. Or if you're a nonprofit or whatever, if all of this money talk is putting you off, then your nonprofit can make your dollars go a lot further toward whatever your kind of greater goal is. So dedicated headcount pays for itself, even at this mid scale, to practically maintain custom toolchain builds, which we're going to talk about, create and maintain automated build benchmarks so that you know when your build starts to degrade, and then making that not manual but autonomic. So creating monitoring and alerts for your optimized build so that if it starts to degrade, no one has to tell you, a page duty alert goes off or what have you. And so that way, when you invest the time and the money to make the build faster and you get the uplift in terms of developer productivity, you secure that win so that it doesn't slowly degrade over time and you bleed out and then you have to pay for it kind of all over again. This allows you to kind of pay as you go and keep that dedicated headcount, not keep them busy artificially, but make sure that they have a steady stream of work that's kind of autonomic for continuing to make the build faster and securing those gains.
Hey, Matt, I have a quick question about that. When you talk about dedicated headcount, I remember it was maybe 15, 16, 17 years ago, there used to be build engineers all over the place. And you don't really see that title or role anymore. Have they just become DevOps engineers or SRE or automation managers, or just doing a lot of the same things, but their title has changed?
Yeah, that's a really good question. I would say that a lot of the same expertise is involved as kind of DevOps or release ops or kind of whatever else. And in some companies, there is kind of dedicated release ops or deployment ops or whatever, different people call them different things. So I think that in a lot of companies, the role still exists, but it doesn't, it exists not for making sure that the build is fast, but making sure that when you convey your code or your product to your users, that's done in a kind of a consistent and repeatable way. Because I think that was the kind of first frontier of business continuity nightmares where the release process was manual, or your crypto keys were on a USB key that stopped working, or that kind of stuff, right? I think there was collective.
build machine was under your desk.
Oh yeah, that kind of stuff, right? Yeah, and then or the subversion server was under your desk, and then too much dust got in the fan and it ate itself, right? So I think that those are seen as like really critical showstopper things, but slow builds aren't. And while I think there's a lot of the same skill set, cognitive skill set in terms of problem solving, but also straight up, hey, shell scripting and command line knowledge and knowing how to kind of use a debugger and how to monitor and how to like do that kind of stuff. I think a lot of the same kind of talent and know-how are involved in a release pipeline operations engineer as you would have for someone who would do this kind of work. I just think that this doesn't have the same showstopper. I don't think people perceive this as a showstopper the way that they do for like release ops.
Keith, I was going to say, Keith brought up a good point too, really talking about shift left, right? With a lot of the CI/CD pipelines automated, a lot of those responsibilities are being handed to the developers themselves.
Yeah, so I think that build engineers, going like 20 years, like with clear case and MKS source integrity and
cruise control.
Well, sure. But the cruise control when cruise control came out, it was kind of already commoditized. That kind of idea, right? And cruise control was a kind of a key force and turning point in just like, hey, this isn't worth $1 million a year for a software license. This is open source and it's a real simple thing with a plugin system. And then you have Jenkins and Hudson and stuff like that came later and iterated on that kind of idea. But with ClearCase, you needed to be a PhD in ClearCase to admin that thing. Same thing with MKS source integrity, and maybe to a lesser degree with kind of Perforce. And so I think that and of course, some companies view that barrier to entry as a good thing because it creates kind of knowledge worker lock-in. They kind of invest so much in learning. They can also charge for training. They can also charge for professional services. So why make it simpler? And then of course, open source came in with Subversion and then Git and Mercurial and Codeville and Darks and all these other ones, and just really just turn that on its head and go like, this isn't worth paying. This is maybe not worth paying for. If it's gonna be that kind of complex. And I think what that made some of these companies do is simplify their products so that developers could self-serve. And so I think organizationally, when you have release ops or DevOps, if you're thinking that you're gonna have a 1-to-1 or even a 5-to-1 individual contributor, software engineer to operations person, I don't think that is probably adds up when you're looking at the kind of P&L sheet from a CFO perspective or from just a overall budgeting perspective. You go like, whoa, we can't scale the company this way. And so I think that made people invest a lot more in self-service CI/CD pipelines like GitHub Actions and things like that, where if you're a developer, you just edit the YAML file and you don't need to know the container recipes or whatever, unless you need to get into that level of detail. Yeah. So I think that a big part of it is that a lot of the tip of the spear of this got completely commoditized. And that's not necessarily a bad thing. Like the power is now in the hands of more of the people whose lives get affected. And hypothetically, that means that they're empowered to make a difference or not. These things that we're talking about in this talk, like profile optimizing the tool chain, how do you then distribute that tool chain to the rest of your colleagues and whatever else? And it kind of gets back up above where you need kind of a dedicated function that has the remit and is empowered to do what they need to do to make sure that you can commoditize your profile optimized tool chain. Does it answer your question?
It does. Yeah, no, I appreciate it. And sorry to derail your talk, but yeah, thank you.
Were there any other questions in the chat?
No, yeah, Keith just added 2 PVCS as we were talking through that.
Sure. If we don't reach into our bag of deplorable old enterprise software. Yeah. Yeah, I didn't mean to leave out any, leave out or put in any particular thing.
It's funny though, some of these things you used to hear daily and then you just don't hear anymore. So that's the first time I've ever seen PVCS for years.
Oh yeah, I think MKS source integrity might be another one that people will like, whoa, blast from the past. Thank God it's dead. I'm sure I'm sure it's still around. I'm sure that there's enough old banks that can't get rid of it or something that they have a business. But
Right.
So talking about the legacy code quandary. So one of the pieces of feedback I got from the talk, even though I talked about how I kind of reemphasized over and over again how a lot of these things require no source code changes. I just want to kind of make this explicitly clear because there can be a lack of empathy for people that don't have this problem. But people who have a legacy code base, and Michael Feathers, who wrote the book Working Effectively with Legacy Code, defines legacy code as code without tests. You cannot make safe changes to it, or you can't make feedback-driven safe changes to it. So it kind of goes like this. The code is brittle, or whatever word you want to use, however you want to characterize it. But ultimately, ripple effects are unpredictable. I modify a header file to remove a semicolon or to whatever, and I cannot predict what will happen, good or bad. And then that turns people off to ever trying to modify anything or make improvements. So a good engineer might be like, well, I want to add unit tests so I can make it more predictable, but I can't because the code is so tightly coupled. And then I can't fix the coupling because the feedback loop is too long. I've got a 9-hour build. If I make a change to decouple something and my feedback loop is 9 hours, or even 3 hours, not to be like, I've worked on 3-hour builds or 4-hour builds. I don't think I've ever worked on a 9-hour build practically. So let's make it 4 hours. That's still like, I have 2 feedback loops per day. And if they don't work, you have to be a particular kind of personality to keep at that with that kind of lack of a tight feedback loop. And then I can't optimize the build to reduce my feedback loop without changing the code. So we're going to talk about things where we do change code, but we're going to focus first on the decreasing that feedback loop with effectively no code changes to your C or C++ code, not having to refactor the header files, not having to do that stuff first. There's a lot of gains that we can get if we kind of approach these things in the right order. So some quick vocabulary. So when I talk about link time optimization, that's where the compiler generates a kind of a bytecode in the object files, and then it only does the native code generation and optimization at the final link. This allows it to inline across module boundaries and do a bunch of other great stuff. When I gave the talk in 2013, LTO is still fairly new. And the opinion of LTO at that time was not great. I think those people weren't super well informed necessarily when they said that LTO is awful. But now LTO is this kind of sensible default everywhere. If you're not using it and you have a kind of a modern tool chain that's post GCC 4.8 or so, or post LVM 6 or so, or Visual Studio 2017 or 2015 even, you should look at turning that on by default. And there's profile guided optimization, which is sometimes called feedback driven optimization. That's PGO and FDO. That's where you compile your sources with the specially. It makes a profile generating kind of binary. You exercise that, you run it. And then you take that generated profile, feed it back into the compiler, and it produces more optimized native code. It'll reorder branches and do things like that. Then on top of this, now you have a thing called Bolt from the engineers at Meta, the company formerly known as Facebook. So Bolt does code layout optimizations leveraging PGO data, and it operates on top of, in addition to PGO and LTO. And it's kind of a post-link optimizer that will reorder the code to get much better spatial locality and much better kind of cache performance and branch prediction performance as a result. And then the last thing is the -march option, or the -mCPU option, allows you to generate code for a very specific CPU. And if you have a standardized hardware fleet for your developers, MArch and MCPU can produce much, much more optimal code when it knows the exact characteristics of the L1, L2, and L3 cache. And it knows exactly what the pipeline is like and what the latency for certain instructions is like. And also various details of SIMD, like, hey, should I use SSC4 or is that not profitable on this CPU or this pipeline? These are all reasons to use MArch. And then the last things here is Ccache is an open source project that creates an on-disk cache of object files. And that cache is indexed by the preprocessed source hash plus your kind of compiler binary hash and your compiler arguments, basically. And it works very, very simply by pre-printing the Ccache command. As I'm going to talk about later, Ccache is not necessarily the place to start. DistCC is an open source project that distributes compilation by transferring preprocessed source to other nodes for compilation. Both these projects are now actively maintained. I haven't gotten a chance to deploy those at scale since my last talk, but I did get some success with them during my last talk, and I can see by looking at the release notes of the last even 3 years that they've both made huge leaps in how they work independently and how they work together. So I think that the results that I got at the company that I did my case study at will be even better. So if only it were simple. So why not just use Ccache and DistCC? I just stick a command on the front of my compiler thing. I don't modify any source code, and I can edit the build scripts to do that. Am I right? And the kind of wooden shoe in the gears there is that both of those tools rely on pre-processing source code, and that being fast. And the gains from Ccache and DistCC separately and together, or any other build distribution system, are poor if the pre-processing is slow. So what would make pre-processing slow? Giant transitive closures of header includes. So any file in your build, if you take the compiler command line, take the -C for compile out of it, and add -E for preprocess, look at how big that file is. And if you've got a 10-line source file, but your preprocessed output is 900 kilobytes, and that's a real thing, that's not an exaggeration, distributing your build is probably not the first step that will get you the best bang for the buck, especially since distributing the build requires infrastructure. You gotta have agents, you have to have nodes to install the agents on, so there's a overhead there that can be worth it, but maybe not as a first step if your pre-processing is slow to begin with. Then you have slow network IO, and in a lot of enterprise environments or even home environments, now that a lot of us are working from home, your Wi-Fi might seem fast, but if you measure the latency is what really comes into play, even as important as the throughput for these kind of build distribution things. And then slow local disk IO. How busy is your disk at that point in the build? And if you're trying to parallelize it that much, does your disk IO ultimately kind of become a bottleneck, or your operating system or its file system of choice or its file system cache become kind of a bottleneck? And then you've got unnecessary include in library directory searches when someone just says, screw it, I'm just going to add every include path onto the front of every command line, every compile command line, no matter what. Well, it's going to do a lot of stats across a bunch of directories just to fail 50, 60 times, depending. Same thing for the library for your linker path kind of stuff as well. And then doing things that kind of unwittingly invalidate the Ccache cache, where you're going to get a cache miss on 50% of your files every single time. We'll talk about kind of how that can happen and how to get around it. So DistCC needs a fast, low latency local network. And depending on your setup at home, whether you're an Eero customer or a Linksys customer, whatever hardware that you have, you might have really great throughput, but maybe not the best latency. even in an enterprise Wi-Fi kind of deployment. So these are things to really explicitly measure and get into the nitty gritty of before you decide to bet on the simple thing of, well, let's just distribute the build.
Hey, Matt, real
yeah.
quick. Yeah, yeah, I want to open up a couple of questions, but then also there's a red line on your screen. I don't know if you see that. I don't know if it's like the
I do see it, and I don't know where it came from.
whiteboard or something. Yeah, if you can't
I didn't do it.
remove that, then don't worry about it. No problem. Well, let's open it up. Does anybody have any questions? I don't see anything in the chat, but if you want to come off a mute, now's your chance. We'll give you a second here to come off a mute and ask any questions you'd like to Matt. There it goes. All right, we'll pause again too for more questions, and then we'll have time for Q&A at the end of the talk as well.
Cool. So accelerating the work, no source code changes. And again, I'm just really emphasizing this because this was a point of confusion or feedback I got from the previous talk. But the first thing is to make your source checkout and update fast, like really fast. And I'm not calling out these projects, but for instance, when I clone WebKit or GCC from GitHub, and not calling out GitHub either, that is not a fast operation. There's ways to speed it up. And so this is one of those things where even before the build, the first part of the build, especially in CI context, is the checkout. So making sure that your pushes and your pulls or whatever the verbs are in your source control of choice are fast is really important. The second thing is to use RAM disks. Third thing is to use a modern linker. And even if you're in the Visual C++ ecosystem, or the ARM proprietary compiler ecosystem. I'm sorry? Sounds like somebody came off the child. Okay, there we go. Is to use a modern linker. We'll kind of go into those details. Optimize the compiler for your environment and for your source tree that you are compiling day in, day out. And then optimizing remote file system servers and clients. If that still comes up, I don't know that this is still a thing that people do necessarily. And then there's parallelizing the work and then using Ccache. So making the source checkout fast. Do simple transfer rate tests for pushes and pulls. Do manual load tests with concurrent clients. Automate that, and then monitor your source control servers, CPU, RAM, IO utilization, and throughput, assuming you own the hardware there. Even if you don't, I would put monitoring agents onto your kind of enterprise cloud nodes so that you know if there's any hiccup there. And if you see any use of swap during a build, that's one of the first things to try to solve for. As soon as you're swapping, the build performance is kind of out the window, no matter what. And again, set up alerts for degradation, monitoring and alerting, secure your wins. Don't spend a lot of time to fix it, just to have it slowly bleed out again over the course of a year or 6 months. Using a RAM disk. So mounting your temp directory as a RAM disk, or mounting other mounts as kind of a RAM disk. Certainly putting your build output in a RAM disk, so your object files that are LTO or native are all there in the RAM disk. I found in my benchmarking last week that tempfs on Linux is still the fastest thing to do in my benchmarks when I booted my Surface Book into a bootable Linux distro running Linux kernel 5 something. Some people came at me with like XFS is faster or a journaling file system is faster. I don't know why a more complicated file system would be faster. But I would encourage you that if you have an alternate opinion, just make sure that you benchmark it and that you automate that benchmark so that as you update your operating system distribution or your operating system version, that you know that stays fast and that your measurement continues to hold true. And that's the best bang for the buck, even with the best SSDs, even with even today. This is something I said before 2013, I'll say again. So the best SSDs, when you're using an ASIC with specialized compression, you get 9 gigabytes per second. And that's not striping, or there's other stuff you can do, but that's versus 448 gigabytes per second. Which you can get approximately when you distribute across all of the cores on an M1. Each core has a kind of a memory bandwidth saturation limit that your RAM disk would then run into, but you can get crazy ass fast stuff with a RAM disk still. That has kind of leveled up. This is still something to measure because if you're, and to verify on your fleet of hardware that's being deployed to your developers. But in general, RAM disk, I would still say, is hands down the kind of best thing to do. And that's on Mac OS and on Windows. And there's commoditized knowledge out there now. This is not like as esoteric as it was almost 10 years ago when I originally did the talk. Often when you have it that fast, when the IO is that fast, that's when your real bottlenecks come to the fore. And you can actually see that noise that was of this IO being slow. Again, even for a fast SSD where it's crazily fast, you can still get enough serialization there where you can't see the parallelism problems with some of the other part. The thing about this that's great is there's no source code changes. You can do this with your old compiler if you got GCC 2.8 because you need to deploy on an S390, that's who knows what, right? If you got some really unique situation, you can still make a RAM disk and kind of go from there. 1 second. Right. And as a result of favoring RAM disks, your dev laptops and workstations should have really a minimum of 16 gigabytes of RAM. But at this point in the year of 2021 and 2022, I would really advise shelling out for the 32 gigabytes of RAM, not so people can have 9,000 Chrome tabs open or Firefox tabs, whatever your browser preference is, but so that you can have a RAM disk of the appropriate size. Not just for this situation, but also when we talk about C cache, using a RAM disk for C cache is key, is very important. Whoops, wrong one, sorry. Using a modern linker. So this was really fun to investigate, to reinvestigate. So originally I said, hey, gold is the thing to use. Don't use BFD unless, again, you're in some weird obtuse operating system or binary file format that only the BFD, the original GNU LD linker supports. And that's really exceedingly rare. But now we've got Mold, which is hands down the fastest in my tests. When I use Mold to link Clang itself, that final link time goes down from 114 seconds to 8 seconds. And part of that is that Mold versus LLD, versus Gold, is that Mold just really saturates all the CPU cores that you have. Gold does not, even when you enable threads, and even LLD doesn't saturate the cores the way that Mold does. Mold only supports ELF and userland right now. So if you are working in kernel land in Linux or FreeBSD, LLD is the default linker in FreeBSD as of about a month ago. LLD has become the default for kind of a while now. So LLD also threads across cores by default. It's not super fine grained though, so it doesn't. If you have 32 cores, it's not going to saturate those, even if it could necessarily with the amount of work it has to do. They all support LTO by default. And LLD, I couldn't find this in Mold, but LLD can also tell you why something was linked and really give you output that's actionable when you're trying to whittle down the dependencies of just superfluous things that are in your build that just don't need to be there. And that goes into the kind of reduction thing we talked about before. So I would really recommend Mold first and LLD. The other thing I would say here is that you go like, well, but with bin utils, BFD, or with Gold, I've really got all these command line options set up to be optimal and whatever else. What I found when I was compiling some old C++ code that I had with these newer linkers is all these options that I had, I didn't need anymore because the new defaults were sane. I didn't need to say GC as needed. I didn't need to, to set WL comma, like a bunch of options. It just worked. It wasn't an add-on thing. These are core features that are built in as part of these things emitting optimized binaries, but also taking less time to do it. So if you think that there's a command line option here, they're like, well, Mold doesn't support -WL comma something or another, I would just try it as a drop-in and have it tell you, given the final binary, what any problems are or what link problems it has, and then work backward from there. I wouldn't assume that just because a specific command line option is missing, that it's a non-starter. And it's the same for LLD. I thought I heard a noise. Does somebody have a question? Going once?
No, I don't see any in the chat either.
Okay. So for the gold linker is still appropriate, similar to BFD, when it supports a binary format that, or an operating system or something that you are kind of stuck on. What I would say is that if your build infrastructure is on physical machines with operating systems that are this old, it's a security and continuity risk. Consider investing in a cross-compiling setup so that you can build on modern OS and hardware and produce binaries for your legacy environment. One second, I told this to do not disturb and it did not listen to me. And a lot of this advice for gold still stands. Gold can be threaded. It does not parallelize as well as LLD or mold. You need to enable plugins so that you can use, if you're doing kernel stuff, so it can do linker scripting, but also for LTO. I would just say favor mold and LLD where possible. And LLD for kernel stuff as well. And if you think that you're stuck, think about that cross-compiling situation. Setting up a cross-compiler is not the investment in voodoo and black magic that it used to be. A lot of that is very smooth and just works now, and may be very much worth your time, especially if you have a business continuity or security risk by being on a, I don't know, Red Hat 6.2 or something like that. I'm not calling out Red Hat, just a old operating system. The BFD linker, if you're on an OS that's more than 15 years old, again, and consider investing in a cross-compiling setup. And I talked about this earlier, but I need this config option that only the BFD linker supports. And I'm gonna say default to you ain't gonna need it. Plug in one of these other linkers and without setting that option and see if it does just work for you. They're just saying optimal defaults in mold, LLD, and gold for all intents and purposes that can reduce that link time by 10x or 20x. And that's not an exaggeration. Reminder that using the linker with plugins requires rebuilding the tool chain with that linker. So getting LTO in place or getting linker plugins in place, the relationship between binutils, BFD, and GCC or Clang becomes more arduous as well. There's stuff that you have to do at compile time of the tool chain that these other linkers just do at runtime with options or configuration options. And then the last part of the section is so using the profiled bootstrap target and the bootstrap LTO config for GCC. And Clang has kind of a similar setup by default. And depending on your OS distribution, your Linux distribution or whatever, this may already be set up for your tool chain. But there's an important thing, which is when you're doing a profiled bootstrap and jittering that profile guided optimization of the compiler, your code isn't anywhere in there. It's profile optimized for compiling the compiler itself, which is still better than nothing. And I saw a 20% reduction in pre-processing times just by profile optimizing the GCC for 5.0 or 5.1 on a C++ code base I was working on at the time, without including my code base anywhere in it. And if you're on a really old GCC, because again, you need some legacy platform support, even for a cross compiler, and you have a C++ build, have GCC compiled itself to C++. That's the default now, but in pre 4.8, you had to configure it specially. So optimizing the compiler. So when you do a profile bootstrap, it's going to profile optimize for GCC's code base itself. And Clang is kind of the same way. So the trick that I did way back when was I would go into this kind of easily accessible header file in the GCC sources, include #tab.h, and I would put an ifdef C++ at the top, and I would say, here are my changes, include some header file that I care about. And in this particular case, I'm instantiating a particular template instantiation that I want to make sure is covered as part of the runtime profile optimization. Now, this doesn't have to be a system one. It could be one of yours, but you need to make sure that the include paths are set up and kind of stuff like that. And if you have a C++ code base that you're trying to accelerate and it has heavy use of templates, I would put your kind of some of your common or hairy template instantiations in here. And then every time it goes to include #tab.h and it as to the various stages of compilation, that will feed into that runtime profile and help bring down your pre-processing time, your template instantiation time of your build at that point. And this is how you really make it a custom tool chain for your source tree. If you're using static link time optimized libraries, which is a cool trick and a really good thing to do for your application's runtime performance, you can link those in the makefile.in for GCC. And this applies to Clang as well. I just wasn't quite able to get that working in time for this talk and take screenshots. So you can do the same thing for your linker build, whether it's mold or LLD or gold or heaven help you BFD bin utils. So you can set those CXX flags to be O-fast or O3 or whatever. You can set the arch to be native, so whatever CPU you're compiling on, or you can set it to be the exact CPU that your developer kind of hardware fleet is. And you can build those with link time optimization. You can do the same thing for your static analysis tools. So if you use Flexilent or whatever, anything that's processing your source code, you can profile optimize to make it parse your source code faster. And in some cases, the uplift can be a double-digit percentage in total time reduction. Just make sure that if you're going to use O-fast or be fancy, make sure that your test suite still passes. It works almost all the time, but O-fast in particular does some floating point shortcuts that not all code bases are resilient to. I'm going to kind of skip over this a little bit, but I just included here in case anybody wants to go into detail on it during the Q&A. But optimizing your file servers, when I did this talk, two of the companies I had been at, the kind of NAS or SAN setup was a key part of why their checkouts were slow and why their builds were so slow. And so this I have a lot of hard-won knowledge here about optimizing NFS mounts and NetApp appliance heads and how to configure those and that kind of stuff. But I don't think this is as relevant as it used to be. I just include it here for completeness in case somebody wants to dive in the Q&A. But again, optimizing the file servers, there's still no source code changes. Your legacy C or C++ code does not have to change. And then there's parallelizing the work. What parallelization can you get that actually shortens the time? And it's not always that higher is better. Even if you're on like a 32 physical core Threadripper with 64 like SMT cores, make-J63 or is not necessarily going to be faster than make-J48. Always measure and build in monitoring and build in alerting for the monitoring to know that if make-J48 starts to get slower, someone gets alerted immediately so that the work can be scheduled to get it back in line. Here I say make sure hyperthreading is enabled in the BIOS because at the time I got a Dell laptop where it was disabled. And that was a really weird thing. And it turned out it was for DOS compatibility, which was really weird. I don't think this really comes up anymore, but I conclude it here for completeness. And like I said, less parallelism sometimes yields faster builds. Don't assume, measure, and keep measuring and set up monitoring and alerting. There's kind of automated ways to kind of track this stuff now and kind of visualize core usage across processes and stuff like that. So I encourage you to find a tool that works on Windows, that works on whatever, that really allows you to see which one best utilizes the parallelism of the hardware that you have deployed to your developer fleet. When you're using LTO, you can parallelize LTO in that final link as well. You don't really need to do this anymore. The linkers, LLD and all these other things will just do this for you now. But if you're on bin utils with an LTO plugin, or you're on gold and you want to try to fiddle with this a little bit to get better performance, that option is still there. LTO sounds esoteric to some people still. I still run into people like, LTO, what's that? Or I heard about that. That's an experimental thing. LTO is like the base default for almost all of the software that you're using on your mobile devices or on your desktop today. Every browser, every kind of mobile operating system is all using all of this stuff to produce higher performing applications. And you can leverage that same maturity for your tool chain. So Ccache works just by putting it on the front of the command line and put it on a RAM disk, not on a network and not on a regular disk. Make a RAM disk for your Ccache. Even when I tested this last week, I found that even with the really fast SSD in this brand new MacBook, the RAM disk, putting Ccache on the RAM disk was still like a 15% decrease in the overall kind of build time. So the other thing with Ccache is that you can monitor the statistics for unexpected cache misses. This is another thing you can monitor and alert on to make sure that when you get these wins that you kind of keep them. And there's a direct mode versus a preprocessor mode in Ccache, and I would recommend reading their documentation and figuring out what's going to be good for you. And I would test both still in the year 2022. I would still test both of those situations. And then you can use Ccache with distcc. So using the Ccache prefix, and you can profile optimize both Ccache and distcc with a subset of your source code. It's not a bad idea. They do kind of look at that to like get all the include paths out to figure out what they need to bundle up and send over to the distributed node. So that's still parsing your source code, but it's still, so that's still something to profile optimize and use bolt on. Distcc, I'm not seeing a huge win, but I did not test it on a hardwired gigabit Ethernet connection. I was doing it over Wi-Fi, over a VPN, and it still wasn't profitable, or as profitable as I would kind of expect it to be, given the overhead of having to install the nodes and agents everywhere and that kind of stuff. So I would try distcc last after the reduction of your build. Distcc with Boost is better than it used to be, but because Boost has a lot of templates have a lot of things in header files, so the transitive preprocess closure can be quite large, and that is what can kill the effectiveness of it. This isn't a diss against Boost; it's just the nature of C++ pre-modules. Of like C++ 17 and before. So it can still be a win. This is the thing I would definitely take the time to measure and verify in your situation and figure it out. And so as a result of that, I think distcc is something I would do last because all this other stuff is more of a complete slam dunk in terms of gains. Any questions? I see the chat number went up, but.
Yeah, the thing in the chat, if you'd like to take yourself off the mute, feel free, ask Matt anything you'd like. No questions?
All right. So I'm going to spin through this. I think this is kind of covered in the original talk, and this really hasn't changed. Just reducing what gets built. Are you compiling things that you don't even link in? Are you linking in things you don't even use? Eliminate that stuff. Even in a legacy code base, if it's actually not used, it's pretty easy to kind of chop out. It's just that it can be difficult to discover that stuff. But these modern linkers have options to help you discover that stuff more readily, which is really great. So sources that are compiled but not used is one thing. Sources that get recompiled multiple times because they're using a preprocessor defines to kind of modify the code. headers that get parsed unnecessarily because for declarations aren't being used. And then debug symbols, FET LTO objects don't really come up anymore, but there's other things that also introduce more IO that can be kind of challenging. And I'm just gonna kind of spin through this because I think it's relatively self-explanatory, and just leave it for Q&A if anybody wants to ask any deeper questions. But sources that are compiled to objects but not linked, and that sounds like, who does that? I cannot tell you how many times I've been able to like take like literally a couple of minutes out of a build just by looking at doing a comparison of the compiler output per source file name and per .o output, and then looking at that and then comparing that with that final link command line and going like, oh, here's literally 20 things that are compiled but not linked in anymore and not used in unit tests either. So it sounds silly, and it is. But again, if no one's monitoring and no one's monitoring or alerting on stuff, these are the kinds of little crafty things that can kind of happen that are good because they're easy wins. And then objects that are linked in, but could be eliminated in linker GC, depending on how old of a linker you have. And if you have, if your linker does do garbage collection or unification, if you're an old enough linker, it might not. Objects that are kind of linked in, but aren't used. And LDD and these other tools all have things that can kind of tell you stuff that you're linking against that you don't need to kind of be linking against, which is great. And this WL as needed is just for kind of BFD and gold. You don't need it for LDD or mold, I don't think. Sources that get recompiled. If I have a socket.c and I'm kind of recompiling it 8 times with -d Linux, -d whatever, I'm going to have problems with my C cache per kind of compilation of that file. And if that's a large file, maybe this one is not a large file, it depends. Shifting defines to be separate source files where I have the common code in a separate file, and then I have the platform specifics in a different file, and I let the linker do that resolution for me. Especially with LTO, having those in separate files doesn't mean you're not getting inlining and stuff like that. And then a really common one I saw that was kind of invalidating C cache stuff, favoring a version .c or .cpp instead of a -d version or an under date for your version. Anytime you have under date, cache isn't going to work. Every time it goes to preprocess that, it's going to get a different date. And there's tricks that you can do to make it so that the date gets injected and whatever else. I would say figure something else out that actually uses a compiled translation unit instead of a preprocessor define or kind of a header file injection situation. And then shifting preprocessor defines to runtime composition of specialization, passing in a function pointer of the thing that's specialized. And again, devirtualization and LTO can optimize across those boundaries now. So making something a function pointer that you pass in to kind of get that runtime composition doesn't necessarily mean that you're losing out on inlining or const folding. And then using function pointers or virtual classes as parameters. And then if you have implementations of things that change a lot, that's what I mean by volatile, getting those out of header files. If there's a header file that kind of gets updated because there's an implementation in it, that is very, very common, or that has a lot of changes to it, and it's in the header file because someone thought you needed to do that to get inlining, you don't really need to do that to get inlining anymore. And you should always, if you want something to be inlined, you should verify with a disassembler that it actually is getting inlined. So in those cases where you have a volatile implementation in a header file, shifting that into a regular translation unit, a C or a CPP file, so that it can get cached and its high rate of change doesn't end up causing rebuilds for a lot of engineers. Header files that get reparsed, nothing. I mean, profile optimizing the tool chain, all that stuff is all great. The way that I took a 3-hour build and got it down to an hour before I got into the toolchain optimization was refactoring header files. And I'm sorry, but that's just, it was super tedious. It was going through and making things for declarations, getting rid of stuff that didn't need to be included, kind of refactoring the header files so that there was a better cohesion or a better separation of concerns, applying the interface segregation principle. That was the biggest bang for the buck, but that is source code modification. Even though it's just header files and it is just declarations and stuff like that, if you're super nervous, all that other stuff, it still has great uplift and you should do, and might still be the best bang for the buck to start with. And then reducing disk IO, the main thing I would just focus on here is make sure your include and your link paths are optimized for the module that you're building at the time. The more that you have in there, the more stats it has to do that are just going to lose. And that's stat is slow, even if you think your file system is fast, and even if it's on a RAM disk. And then the last thing is just shifting the culture. So when you have slow builds, there's a lot of waiting and context switches. And fast builds mean less playing ping pong. And this is a very specific thing. I was at a company where that had the 3.5 to 4 hour builds. And when we got the builds down to 10 minutes, one of the questions I got in an engineering all hands was, when do I get me time? And I didn't, in my head, I'm like screaming, but I was like, at home. So now you can really focus on work and whatever. And literally the people that had ran the ping pong championships were upset because they're like, well, now people won't have time to play ping pong. This was a real conversation with real adults that happened. So there's a shift that can happen where people get used to these broken windows, or get used to this waiting and the downtime. And if there's less downtime, that's something that you want to figure out upfront, how you're going to communicate what you're now going to do at that extra time that you're kind of getting back. You can still play ping pong and say, hey, we're still going to play as much, we're still going to play 4 hours of ping pong a day. But I would definitely plan for those conversations and how you kind of want them to go. Most people do love getting more done every day. They love the shorter feedback loops. It's not really a problem for most people, but there are really entitled people that just only want to work 3 hours a day, and slow builds let them do that. So yeah, and I think the big thing here is it's perfecting, not perfection. There's always something you can do to shave this down further. You can run Intel vTune on the tool chain and see exactly, even after you profile optimize it, where the cache misses are happening and where whatever. And so I think that the thing I would just say for people in a leadership position is this is something to, actively fund every quarter or every year, more or less, because there's always kind of more that you can do. And the more developers that you have, the higher the multiplier is for these gains. So yeah, reducing the amount of code you compile and accelerating it in lockstep is something you can parallelize. Refactoring your header files at the same time you're customizing your toolchain is something you can do kind of in parallel. And the other thing I would really highly recommend is get a toolchain support contract. Whether it's Clang or GCC or Microsoft and Visual C++ are a little bit different. Getting an SLA out of them is maybe more challenging. I don't know. But get an SLA for fixes to compile time regressions. GCC 4.7 to 4.8 or Clang 6 to 7. Every tool, Visual Studio, actually Visual C++ 2019 to 2022 has situations where all of a sudden build time regresses. And if it's knowing it happens and having the monitoring in place is key, but if you don't have a responsive vendor on the other side of that can help you get that time back, that's a kind of a liability. So I would really encourage people to look at a toolchain support contract that has an SLA for fixes to compile time regressions. So the conclusion here is builds can be made much faster. However slow you think your build is or how impossible your situation is, I personally have hands-on been in the belly of that beast with legacy code that was hard to modify or impossible to modify, where everybody was afraid and everybody was kind of frozen in time, and was able to make progress incrementally, step by step, and get those improvements deployed to hundreds or in some cases thousands of developers with almost no changes to source code and a very minimal capital investment. And there's a fantastic return on investment for even medium-sized orgs. Like I talked about, even 20 engineers, if they're spending just a few hours a week waiting for builds, you get a year back. Even at 40-week work year. So that's the end. My Twitter handle is SYKE. On LinkedIn, I'm Matt Hargett. And if you want to find my music, I'm The Making of on Spotify, iTunes, Tidal, and every other digital storefront. So thank you, and happy to take any questions.
Thank you, Matt, very much. I love the ping pong reference. When I saw that, when you brought that slide up, I thought it was more figurative ping pong, like ping ponging with
literal.
people back. Literal ping pong.
Literal ping pong.
Yeah, I mean, that's interesting. Like a big change like that reduces those wait times. Yeah, might require some sort of cultural considerations within your organizations.
It was one of those things that was a surprise to me because I thought everybody would be over the moon.
Yeah,
to get
right.
that time back. And when it wasn't universal, it was a surprise. And so hence I capture it, talk and commoditize it.
I'm curious that Amir, you're on. I don't know if you're still at your computer and come off of mute, but I don't know if you've seen any of that. So Amir is the developer advocate at Incredibuild, and that's what they do, right? Is they help people speed up their builds too. Have you seen things like that too, where it's like a cultural issue? And
this is the exact same scenario. So I was following very tightly with the talk. So thank you, Matt. Mm-hmm. And the last point that you mentioned regarding having SLAs and contracts, I'm with you on that. Eventually, if you find yourself, instead of writing code, investing time in chasing the tool chain, this is quite problematic. And
yep.
You know, this is the tool. You want the tool to work for you. So yeah, I agree with that.
Yeah, and I think the other thing also with getting paid tool chain support is if you have an emergency situation like Spectre mitigation or other CPU level exploit mitigation, where if you think like, oh, I'm safe, I'll just stay on this one version of the compiler. We've had enough of these CPU level exploitation things that required like a tool chain upgrade. For me personally, it's better just to know that it's taken care of and that the risk is mitigated. That if I am force upgraded to a compiler with Spectre mitigation, I'm not all of a sudden going to double my build times and then have to reset expectations for all of my deliverables for the year because the productivity goes down. That's not a happy time to have to explain to your C-suite or to your public investors or whatever, right? So I think that that's another thing that kind of comes into play is people like, oh, well, I can stay on playing 3.1 because whatever it's, but if you're conveying in a way that you're vulnerable like a Spectre, I'm not picking on Intel or Spectre, just it's one of the more recent ones, that may not be within your control to safely stay on that kind of old compiler.
Right, and that's it is not that you have the personnel to maintain the compiler or the toolchain. So you have to focus on your day job on implementing your code and project and have the entire ecosystem work for you. Yeah. A question regarding cloud. Is cloud something that is being considered? Is it being part of the equation? Can it go in as something that can assist with compilation time?
Yeah, I think that the main thing is what is the latency between the different build agents. And so like GitHub Workspaces, which is a feature that they just launched, you can get a 32 core like machine to yourself. It's if it's being co-located or if it's being virtualized in some way, they're hiding it really well. And so in that case, the build agents are all the cores on the thing. The latency is measured in nanoseconds, right? And so I think that if you're going over a VPN or going to a public cloud, like DigitalOcean or AWS or kind of what have you, that's the kind of main thing is what is the latency of it getting your code, whether it's pre-processed or individual source files or whatever, out to those agents, and then it reporting back. And it's not just the throughput, like, hey, I've got 1 gigabyte up fiber or whatever. It's what is the latency there. And that's that latency more than the throughput is where I've seen the potential value proposition be turned upside down, where it's like, oh, this is a lot worse. Distributing it is a lot worse just because the latency cannot seem like a lot, but in comparison to, do I pay for 16 core 32 thread laptop, or do I pay a public cloud provider? Especially one that you're already on board with and whatever else, that can seem like a no-brainer. but I would still measure, and I would measure in the environment that you expect your developers to be engaging with that cloud service. And I'm not against cloud services. A bunch of things with this works great, where the differences in latency don't matter. But it's a different ball game if you're uploading your source code and then typing make in a remote shell. It's still, then it's all co-located, hypothetically speaking. And that kind of, even data center to data center fabric, because that's often for these things is all specialized and very low latency. And they've got their own kind of backline from data center to data center, depending on the geography. That can still like be huge, but from your house to the cloud might not be huge. So it really, I'm not trying to be hand wavy. It really depends. And so I would say that I would measure it, but if you had to choose which one to try first, I would take a look at what's the high-end laptop you can give to your 5,000 developers first, and then look at cloud, any kind of cloud service as an augmentation to that.
Even though working from home, we are diverse already. So it's not, we are all in office and you're using the on-prem resources. Well, you're using maybe another machine that is not near you.
Yeah, no, that's true. And that's why I said like VPN, going over the VPN as well, same kind of thing. And I'm not picking on VPNs. It's just like that crypto isn't free, and depending on your VPN concentrators and how they're configured or what the load on them are, like if you're a company that's growing, but you're not scaling that VPN infrastructure as your company grows, you can start to get, again, slowly get less and less performance or higher latency. Also, some VPN concentrators and similar kind of middleware, network middle products favor throughput instead of actual latency, because it's an easier marketing thing, right? Or it's a product choice. It's a product choice. And so there's no clear-cut answer for that, I don't think. But I do agree that if you're VPNing in, you are using a cloud. It just happens to be your corporate cloud.
You brought up the point too of build avoidance and build caching, and maybe that's where this really becomes more feasible for a lot of people, right? If you're rebuilding a lot of things in AWS, you're paying to rebuild stuff you've already built. If you can avoid that, then it makes the costs, maybe that's what really moves the needle for you in terms of leveraging the cloud.
Absolutely. And so I think that there's like to me, and just my personal, I think there's a logical order to try these things in terms of how much, like in the case of like offloading built to a cloud, even if it's your own AWS instances with your own images and your own whatever, is, well, now you're sending your source code across the wire to whatever. So you got to talk to your security team and your compliance team and a bunch of other stuff. And in case of AWS, like there's SOC level 1, level 2, they got all these things figured out, but that's still kind of a rigmarole. And you have to work through the bureaucracy that is there for a very good reason, even within your own company, to kind of get some of that stuff done. And so something like just dropping a new linker doesn't require that conversation necessarily. And the linkers are all licensed under licenses that probably are not banned in a company, for instance. So I think that there's kind of a logical order to come at things in terms of how much administrative overhead, and sometimes that administrative overhead isn't technical administration, it's also kind of legal contract administration or security stuff when you're interfacing with those colleagues, that once you're putting stuff out over the wire, especially trade secrets, you're in a different area that requires a lot more conversation, and for good reason, and for very good reason, right? So I think that that's another kind of factor there to take into account.
Sure.
Just before we summarize, I feel that we are at the summary stage. If we can go back to the numbers, the estimated number of lines of code, and the total compilation time.
Yeah. Yeah, so if you have 20 engineers, that it's not that each of your build takes 2 hours, but they total spend 2 hours a week waiting.
On what size of a project?
So 20 engineers times 40 weeks per year. So
I
like-
mean the project that we're compiling. Can you have an estimate of how many lines of code? Which, you know, it's a very rough estimate of the complexity or the size of what we are compiling. It mainly eventually depends on our dependencies and many other things, but just to have the notion, to have the feeling of the size.
For a 2 hour build, or
yeah, for the 2 hour build, yes.
Oh yeah, so for like a 2 hour individual build at the company that I was at that time, that was about 1.5 million lines of code.
Okay.
And that got down to it was a little over 10 minutes. It was like 10 minutes and 40 seconds or something like that.
From the 2 hours.
Yeah, from the 2.5 to 3 hours. Yeah, and the build machine was swapping all the time. We put more RAM in it. We did the RAM disks thing. We profile optimized it to like, and we did all that stuff. And everything had an incremental gain. Almost everything had an incremental gain. And then by the end, it was 10 minutes times that organization was, I think, 250 global developers, maybe 300 global developers. So 300 developers times, 2 saved hours a day. Not a week, but like a day.
I totally agree.
I earned my salary on that one. For sure.
You raised something there that it is not only the time that you save, it's the potential gain in having the feedback earlier. So if something fails, it fails earlier. You can ping pong, but while you are thinking about what failed in the testing. So go play ping pong. But when you have in mind, I have something failing in my tests, not I'm waiting for the build and I don't know even if the test would pass or not.
Absolutely. And, at that company, I was brought in to help them with an agile rollout. And part of that was unit testing. But I was like, if your build takes 3 hours just to be able to unit test, that's just like a non-starter. So they had a quality problem. Their support costs were skyrocketing, but their revenue was plateauing. And you don't have to be like a MBA to figure out what that means. And so getting the kind of horse before the cart on that was, well, the build times are the main thing. And if we can get the build times down, your feature velocity should go up. But then once the build times are down, then we can add runtime feedback in terms of unit tests, but also using Valgrind. This is before sanitizers were super common, but now it'd be like thread sanitization.
Analysis.
Exactly. That company was a public company, and then they got taken private, and then they got sold to a big conglomerate for a ton of money. And one of the reasons I think that they were able to kind of cut their staff and not die completely was we had that gain. And it really allows a lot of fungibility in terms of not just scaling up the engineering organization, but scaling down the engineering organization and still being able to have any feature velocity and still kind of get things done. Or as you grow an organization, and ironically, sometimes you grow an organization, go from 100 engineers to 200, and somehow your feature velocity stays the same or goes down because these little debts build up and then they kind of get compounded. So yeah, for me personally, there's a culture thing, and there's making the individual contributors feel good and feel like that they have a culture of ownership and that they're empowered and that people care about how their time is spent. But then there's also just this just plain dollars and cents aspect of it, where it's in terms of feature velocity, or if you're a nonprofit, making sure that your donated dollar or your however your funding is, that those extra dollars go further to getting homeless kids off the street or whatever your kind of thing is. And this can be a really key part of it. Just getting those hours back every day times the number of engineers. And it seems like it's oversimplification. It's kind of not. It kind of is simple multiplication to some degree.
Right. Well, Amir, thank you for the questions and the added commentary, and
Thanks,
Matt,
man.
thank you for sticking around. I know we're well over time here, and I know most everyone's got to get back to work here. So I put my email address in the chat for everybody. If anybody has additional questions for Matt or for Amir or for me, please feel free, just reach out to me, and I'll make sure that the right people get the questions for you. This was recorded. We'll do a quick edit on it. We'll get it up on the site for everyone to watch too if you missed any part of this or want to share it. I do want to thank all of you for attending here today and sticking around with us. Matt, a huge thanks to you too. I know a lot of preparation went into updating this and getting ready for today. And I really appreciate you for sticking around for nearly an hour and a half to talk to all of us and giving us your time like that. We really appreciate you supporting the community. And a quick final thank you to Incredibuild, who is also the sponsor of MLOC Group in this event here today. So thank you to all of you. So Matt, thank you again, and I really appreciate you. We'd love to have you back to talk to the group again at some point.
Awesome. Thank you so much for the opportunity. I really appreciate it.
All right. Thank you, everyone. Thanks for sticking around. We'll see you on the next one on February 10th.
Thanks,
you, everyone.
Thanks, everybody. Jim, is there any last administrative thing you need me to do? Anything?
No, nothing. If actually, I don't know if you're able to share the slides or if I can share those out with the group with the video as well.
Yeah, absolutely. Let me take a look through my speaker notes to make sure that that those are okay, and I can send you a PDF.
Okay, that'd be great. Yeah, I thought maybe when I posted on the site, just including that with the video so they can watch it or they can download and follow along if they'd like.
Yeah, totally.
That'd be great.
Totally. Yep, happy to do that. All right,
cool.
Thanks again, man.
Well, thank you again. Have a great rest of your week, and I hope to see you in person sometime soon.
Yeah, hopefully so. See ya.
All right, thanks, Matt.